So let's look at one more example of the tangential and normal components of acceleration. So we're going to look at the following. Find the tangential and normal components of acceleration for the helix given by r of t equals b cosine ti plus b sine tj plus c tk, where b is greater than 0. So here, b is some fixed number, it's positive, and so is this number c that's over here. It's just a fixed number. We just don't know what it is. So again, we're going to start by finding a few things like we did in the last problem. We're going to start by finding velocity. It's the derivative of r. So minus b sine t I plus b cosine tj plus ck. And then I'm also going to need the magnitude of this vector, the magnitude of the vector v. If you compute this magnitude, you're going to get the square root, and it'll end up being b squared plus c squared. So I'm also going to need acceleration. Acceleration, it's the derivative of velocity, or the second derivative of our position. So it'll be minus b cosine ti minus b sine tj, and then 0k. So we're ready now to find our tangential component, a sub t. That's v dot a over the magnitude of v. So I'm going to compute the dot product of v with a. So I'm going to multiply, I'm going to get b squared sine t cosine t minus b squared sine t cosine t over the square root of b squared plus c squared. But if you look in the numerator, you're going to get 0. So our tangential component of acceleration is 0 here. Now if I look at the magnitude of a here, you'd see that the magnitude would be b, because b is non-negative. And so now our normal component, a sub n, of acceleration, remember there was this formula where it's the magnitude of a squared minus our tangential component squared. So here I'm getting the square root of b squared minus 0 squared, or just b. So my normal component here would be b, and my tangential component would be 0.